concepts and terminologies. BGP, concepts and terminologies. What do you know about BGP, sir? Mm-hmm. Anything else you know? Okay, okay, that's nice. You said VXLAN. Nice. The Border Gateway Protocol, BGP. Sir, this is not a normal routing protocol. The normal protocols, they are within enterprises. So within within the office, we'll be having various subnets. To reach those subnets, we need a routing protocol. In a large network, in a large office, in a large enterprises, we'll have many networks. To provide reachability using best path, we use protocols like OSPF, ISIS, EIGRP, ZIP, etc. But they're not good enough to be used between autonomous systems, between organizations, between enterprises, or between data centers. BGP is the protocol which has got that capacity, that capability, that advanced way of sharing information. So BGP is the best protocol whenever you have more than one border connecting. For example, a company connecting to an ISP. Now, how many borders are involved? Two borders. One is the border of this company. Another is the border router of the ISP. Two devices are involved. Now, BGP is Border Gateway Protocol. So the name itself says that this protocol works on the gateway, works on the edge router that are in different borders. This is the protocol that works on the edge router that are in the borders. Border Gateway Protocol concepts and terminologies. BGP, Border Gateway Protocol. If you see this picture here, you can see various borders. A and D are in two different autonomous systems. A is in 65500. D is in 65000. Two different autonomous systems. This is 000, this is 00. This is one autonomous system, this is another autonomous system. Likewise, you have here B and E as two different autonomous systems. Now, between these enterprises, between these autonomous systems, we'll be having some policies in distributing the routes. See, what is distributing the routes? Giving routes, getting routes. You will have some policy in giving and getting. You won't be freely giving and getting as you used to do within office, within an enterprises. Within an enterprises, it's your own routers. You freely give and you freely get. You don't have much policy. But between autonomous systems, you will definitely have policy because you are talking to someone, not your own, isn't it? Okay. So you see, between the autonomous system, there will be always some restrictions. There will be always some policy in giving and taking. No, see, this is also an autonomous system. Autonomous system is group of device that is under single administration. See, this office is under single administration, right? This is under another administration. This is another administration. So you have a lot of companies. You know, each company is an autonomous system. Not only ISP, ISP is also another company. Their job is to provide service, connecting people. It's a service. They're also one company only. See, Amazon is also a kind of service provider only. But they don't provide internet service, they provide some other service. So everyone is an enterprises. ISP, if you don't see the internet sharing thing, then they will also be considered as one enterprises only because they also have got internal employees. Like your office having employees, ISP also have got admin, housekeeping, front office, admin, production, a lot of things. Even ISP have got a lot of departments inside, like in enterprises. They also have HR, they also have employees doing various projects inside. Anyway, if you have collection of routers, collection of switches, collection of devices under single technical administration, then we call it as an autonomous system. It's an autonomous system. Now, between two different companies, if they want to communicate, they won't freely communicate, as I said. They will have some restrictions. They will have some agreement. That agreement is what? Policy. That agreement is what we call it as policies. Now, do we have any provision? See, you have learned already EIGRP, OSPF, RIP. Did you find anywhere? Did you find anywhere where you can fit some policy in path selection? Did you find in OSPF or EIGRP where you can fit the policy information? No. We saw only metric. OSPF cost is the metric. OSPF cost is the metric. EIGRP bandwidth and delay is the metric using which the composite metric is calculated. RIP hop is, where is the policy there? Nothing. So if you want to tune the path, you need to tune only the cost in OSPF. There is no other option. If you want to tune the path in EIGRP, you need to tune bandwidth or delay. So you don't have much flexibility in applying the policy. So you need a protocol which has got rich in metric, not simple metric. You need a protocol which is full of metric, rich in metric. We call that rich in metric as attributes. We need a protocol which has got attributes through which we can apply the policy that we know that we need our network to follow in path selection. BGP has got that attributes. BGP's metric, they are very rich metric. And BGP's metrics are called as attributes. Attributes. BGP's metrics are called as attributes. Okay. Now, in real world, whenever we have connections to more than one ISP like this ISP has got more than one connection. If an enterprise has got connection to more than one ISP, we call it as multi-homing. Multi-homing. What is multi-homing? Connecting to more than one service provider. What is the advantage? Advantage is reliability. How? Yeah, you got reliable connection to the customers, to and fro between the customer and the enterprises. So reliability. First is reliability. Second is best path or performance, improved performance or accuracy in path selection. How? See, you may be having customer worldwide. Now, if you go via ISPA, you can easily reach these customers. Short. If you go via ISPB, you can reach this customer easily. The shortest path. So if you have multi-homing, you can take a better path. Instead of if I don't have this ISP, I need to go always like this, which is very far. Because I got ISP A, I can compare the distance and I can take this path, isn't it? So we go for multi-homing to have improved performance and reliability. What is multi-homing? Connecting to two or more ISPs. Why do you connect to two or more ISPs? To increase the reliability and to increase the performance. Increasing reliability is ensured because you got more than one connection. If one connection, one link to the ISP A goes down, you got another link which is taking you via ISP B, as you already said. You got reliability. Second is the performance, as I said. You can have the best path to reach the destinations. Okay, now what is this? In the real world, whenever you have multi-homing, you may have default route given by ISP, and to reach E, C thinks that if I go via B, because B is the gateway, if I go via B, I can go to E, which is giving default route. D is also giving default route, but for C, D is 1, 2 more hops away compared to B. Compared to B, A is far away for C. So C decides to choose this path. And if anything goes wrong here, the default route will not come and it will start going via this way. Do you agree? So this is one style of using multi-home path. When an enterprises have got multi-homing, and when ISP provides default route only, when the ISPs provide default routes only, using the IGP metric. What is IGP metric? Using OSPF, it will see whether going out of A is better or going out of B is better. And it chooses the one whose metric is lower. Yeah. So C chooses B. Maybe here the cost is 10. Here it is 10 plus 10, which is 20. So instead of going this way, it takes this way. Secondly, in the same multi-home scenario, you may be learning few prefixes. Sorry. Oh no. Sorry. What's going on? You know, you may be learning 10,000 prefixes from the ISP and same 10,000 prefixes from another ISP. For example, your company might have might have subscribed only for Google groups of website. So you will not get routes to reach all the domains on earth. Only 10,000 domains, for example. But you may have 1 million domains. You understand what I'm saying, sir? You may be having 1 million destinations, prefixes. But how much you learn? Only 10,000. So what is the advantage? For those 10,000, C will compare going where A is better or going where B is better. Accordingly, it will follow the path. For the rest, you may choose to go via ISPA. See the default route. For the well-known routes, we compare. For the well-known routes, we compare whether ISPA is better metric or ISPB for well-known routes. For all rest of the networks which is not known, you use the default route. And you may have a policy. This is a policy. What is the policy? Use ISPA for the default. Only if ISPA goes down, or sorry, ISP won't go down. Only when the connection to X goes down, you may choose to go via B. Yep. So this is another style, another way in which multi-homing design works. Now the other thing is full route from all provider. You see, all 1 million prefixes are given by both. What is the advantage here? Your enterprises can take very accurate path selection. Do you agree with that, sir? Yes, few thousands may be best to go via ISPA. For few thousand destination, it may be best via ISP B. So you can make a very accurate path selection. Did you get that, sir? All right. So what we have seen is we are having policies. Here, what is the policy? Default route. We allow only default. Here, what do we allow? Only few prefixes. And for all the rest, we have a default route, and the default route should only go via ISPA. Only if ISPA connection fails, then you will go via ISP. And the third route policy is learning all the routes so that you can have a very sharp path selection. Yeah, yes. There are much more policies here. A few examples of what type of policies that we have between the borders to explain what type of policies are between. See, learning route, you have policies. Only when you learn route, you can use the route to go out, isn't it? If you don't learn, then how you will go? No, much. So learning route, here we see some policies. Now, what is an autonomous system? See, this chapter is actually an introductory chapter. Don't expect too much about BGP here. It is simply introducing you to the autonomous system and autonomous systems between which the BGP protocol will be deployed. First of all, we need to understand the environment in which the BGP will operate. First, we need to understand the environment in which BGP will operate. Later, we can go and see how BGP can be applied. Now, an autonomous system is a collection of network under single technical administration. That is what called as autonomous system. What is an autonomous system? An autonomous system is a collection of network under single technical administration. Did you understand this point? Okay, so there is no big definition. It's very easy to understand. All the routers in Cisco is being governed by Cisco people, is being controlled by Cisco people. So that forms one autonomous system, Cisco autonomous system. Every company is an autonomous system because they have their own network borders, their own topology, their own engineers to maintain. Next, what is IGP protocol? What is OSPF? IGP example is OSPF, right? What is IGP? IGP is a routing protocol that is operating within an autonomous system. So we have a picture here which explains that. All these are IGP protocols. They work only within this one. Correct. Interior gateway routing protocol. Interior gateway protocol. Whereas BGP is used between autonomous system. Between autonomous system. Yeah. Now, whether it is BGP or IGP, all this protocol should make sure that there won't be a loop. So every routing protocol, they have some sort of loop prevention mechanism. They have some sort of loop prevention mechanism. BGP. See, internet is a web, isn't it? You got multiple paths to reach a destination, multiple paths to reach an autonomous system. So the traffic may go in the left hand side, the updates may go in the left hand side, and it may come back to the right to yourself in the right hand side. Then loop will occur, no? So how do we prevent it? We prevent it by looking into the autonomous system number. BGP uses autonomous system numbers to prevent loop. Anyway, we are going to get deeper into those things later. Here, what I'm trying to say here is not only BGP, every routing protocol, when they exchange the routing information, they exchange it in such a way that the loop won't occur. The loop won't occur. Any protocol you take, OSPF, router ID is there to prevent loop. EIGRP, diffusing update algorithm is there to prevent loop. RIP, split horizon is there, and infinite metric 15 is there to prevent loop. So you got every protocol, for every protocol you got a loop prevention mechanism. Right? So whether it is BGP or IGP, they don't form loop. You have guaranteed loop free route information exchange. Now BGP is a path vector routing protocol. See, what type of protocol is OSPF? Mhm. Correct. Likewise, BGP comes under path vector. So before I explain you path vector, I want to show you how the loop is prevented in BGP, because this picture can explain you. You see, this autonomous system 700, I'm using only the last three number, okay? 700. Is it okay, sir? 700. 700 is advertising this three network. While advertising, it will say, I am giving you, I am 700 giving you. So this, when it learns that 700 is giving. And then when it gives to this guy, he will say, I received it from 700. Now, this is going to give to this one and this one. When it comes to this one, it says, I will not accept it. Why? Because it has got the from address, who? 700, 600, and then 540. It can see the origin is my own. See, it is coming like this. And you can see the path in which the update is coming. That is why this path vector routing protocol. For example, here in this picture, if you see, in this router here in this autonomous system, if you take one router and see, you can see these networks given by 520. 520 received it from 600. 600 received it from 700. So you can clearly say the path via which the update has come. You are 100% sure that that update did not come through this way, because you don't see this number anywhere here. This is why it is called as path vector protocol. It shows the path. It shows not just the path, it also shows this direction vector. Sorry. It shows the path and the direction. BGP is a path vector routing protocol. Now, in the previous page, we saw the difference between IGP and BGP. We saw IGP operates within autonomous system. What do? They advertise the network information and the metric to reach them that are in that network networks, that autonomous system only. Within the autonomous system, what are all metrics and networks and their metrics to reach the destination and their metrics. But those destinations are not outside the autonomous system. They're within. So within this cloud, you may have many networks. To reach those networks, we have this IGP. Whereas BGP is to provide reachability for the networks that are outside the autonomous system. It shows the path through which you can reach those destinations. How? By using attributes, it is going to pick the path. And the attributes are nothing but rich metrics. Right? Now, what is the specialty of this BGP? BGP allows the administrator to define the policies for how the data will flow through the autonomous system. That's what I was telling you earlier. The other protocols don't have the flexibility to apply the policy. The other protocols don't have the flexibility in applying the policy. BGP has got it. So through BGP, you can apply the policies. The policies that says how the data will flow through the autonomous system. Now BGP, most of the time, not all the time, most of the time, they work like a distance vector protocol, RIP. How RIP works? Hop count, no? Now, for this router, for this autonomous system members, if you go this way, it is only one hop. If you go this way, it is 1, 2, 3 hops. What do you say? So when you don't tune attribute, it will see a hop. Policy will be based on the hops. But the difference is, in RIP, one hop is one router. Here, how many routers I have drawn? 5 routers. No, this is not 5 hop. The entire autonomous system is one hop. Here, one hop is not one router. They don't care how many routers are there within the autonomous system. They only see the autonomous system number. One hop is one autonomous system. BGP can support any policy conforming to hop by hop routing paradigm. So one hop is one autonomous system. Okay. Now this page just gives you an idea when and why BGP should be enabled. When and why. You see, whenever an autonomous system allows the packet to transit through it and reach the other autonomous system, we need BGP. For example, you see, this is your company. This is your remote company. Here is the ISP. Now, ISP is also an autonomous system, isn't it? You are an autonomous system, I'll call 1. Your branch office is autonomous system 2. The ISP is autonomous system 100. Now you see, when the packet goes from 1 to 2, That the traffic, the traffic going from 1 to 2, they will be consuming the bandwidth here, right? They will also be using all the routers in the path, correct? But are they owners of the packet? They are neither sender nor receiver. Then who they are? They are transit. So whenever they are transit, they will have some policy because they need to collect money from you, no? They cannot simply give you the service. But when you are using their network, they will charge you, isn't it? That is what policy. For that, we need BGP. You understood, sir? Second, whenever you have multiple connections like this one, multiple connection, this one, you have policies, isn't it? Sir, if you don't have multiple connection, will there be a policy? See, if I have only one bike in my family, in my house, I will not have any policy. Whether I am going to church or going to a market, I'll use that only bike. I won't have any policy there. But if I have two bikes, then I'll have policy. I'll say I will use only the scooter if I'm going to market so that I can easily carry the vegetable. In scooter, you have leg space. I'll carry the vegetable there. But whenever I'm going to church, I'll go in the motorbike. So only when we have more than one ISP, you can have policy. If you have only one ISP, whether you like it or not, that's the only way you have to exit, isn't it? So when there is no policy, then there is no need for BGP, isn't it? You got it, sir. When you don't have multiple connections, there is no need for BGP. Only when you have multiple connections. Next, when you have policies in path selection, traffic engineering, you need BGP. So three reasons where BGP is more appropriate. Next, there are other three reasons where BGP is not appropriate. Number one, the engineers don't have complete knowledge on how BGP attributes can be used in tuning the path selection. If they don't have clear knowledge, no, they should not do. Why? BGP is a heavy protocol, and when you don't know how to use it, tune it, then there is no use of when I was not knowing how to operate a jeep, one of my cousin brothers said, "Jay, why don't you try driving my car? Try and see," because he bought a new jeep. He said, "Just try now." He gave me. I cannot say to him, "I don't know." So what I did is, I started the car, his jeep, and I put in first gear, and I went very slow. Why? Because I don't know to put second gear in that car. That was not, first of all, the Indian car. The make was not Indian. The gear system was not Indian. It was just, you need to go up and you need to come down. That's all. Up and down. And you will have a lot of some R, F, something like that. Not like Indian system. Six gear, five gear and all. You don't have that. So I just put one gear, which is written like kind of first gear. And it moved very slowly. And I managed with that for 1 kilometer. And he was seeing like what this guy is doing. After 1 kilometer, I said, "Okay, now you drive. Let me see how you drive your new car." Then I found that the secret is it's an auto mm, gear. If I put one more step, if I push one more step, the stick on the top, it will go in auto gear. Sorry there. Because I don't know how to handle it, I couldn't use it effectively. It was only troubling me. The driving was a trouble for me because I don't know how to handle it. It had become a problem. I could have went by walking 2 kilometers by the time I reached 1 kilometer in this car. Anyway, next. If I have only single connection, will there be any policy? And then there is no need for BGP. Third is your router is very bad at memory. Old router. Your router don't have enough RAM. Come again, sir? Of course. Every iOS have got BGP. See, this is talking about very old router. Very old router. They do support BGP, but they cannot accommodate millions of routes. Even your normal iOS routers, you should not use it like this, accommodating all prefixes. Not possible. If it is a normal iOS router, when you accept all the prefixes, then this will go terrible slow and it will stop working. So you need to have a big ASR kind of routers. The routers with a big RAM and resource. Okay. So if your device don't have enough power, you should not use BGP. Next. BGP is a path vector protocol. We saw that, right? Now, same like a distance vector protocol, it will operate like hop code. But here one hop is, yeah, that is very important to remember. Next. BGP to provide reliable communication, reliable updates, reliability. BGP is designed to work on an application layer. So what layer protocol it is? It's an application layer protocol. And when BGP starts working, the protocol that will be given in layer 4 will be 179 TCP. TCP 179. Yeah. TCP 179. Only then the three-way handshake, everything can provide you reliability, isn't it? No. OSPF is IP protocol, IP 89. EIGRP is IP 88. OSPF, I'm coming, wait a minute. OSPF is IP 89. EIGRP is IP 88. RIP is UDP. There's a penal code for fraud in India. What is that? No. 420. This is 520. How easy to remember, no? Yeah. So BGP uses TCP 179. In BGP, the updates are sent triggered immediately whenever there is a change, and only the change will be sent, not the entire database. Incremental, only the changes. And BGP is a TCP protocol, no? So there is no hello packets. What do we call here? Keep alives. So already there. BGP sends keep alive packets every 1 minute. Every 60 seconds, BGP will send keep alive messages to verify whether the neighbor is still connected or not. As I said earlier, BGP uses a rich metric called attributes. No discovery because it's TCP based. First, you need to provide the neighbor address so that it can go and do connection. Yeah, three-way handshake. Afterwards, it establishes when the three-way handshake is successful, it establishes the TCP session and do BGP negotiation. After BGP negotiation successful, then only neighbor will come up. So it's highly secured. Right. Now BGP, as we already saw, it is working between the autonomous system. So it carries huge network information. That's how it is designed. Hmm? So we'll stop